And this is the final recording for the discrete probability distribution, and I will talk about the Poisson distribution. The Poisson distribution is a special case of binomial distribution where we have the very large number of n but very small number of p. If you remember the n in our previous slides, it was the sample size. The sample size is very big, but the possibility of having so this is the possibility of failure. Possibility of failure is very low, but we have large sample. This is where we use the Poisson distribution. And also n times p should be constant. And it is used for rare events where we have large area of opportunity for failure, but failure probability is low. Let me give you one example of how it looks like. So you say that you have pump. In reality, pump runs continuously. It can fail anytime. You can see area of opportunity for failure is very large. It can fail anytime because it runs all the day, all the week, all the year. But the failure rate for pump is 405. It is very low probability of failure. So you can see there is a big opportunity for failure, but the real probability for failure is very low. That's where we use the Poisson distribution. In this Poisson distribution, the main difference between the Poisson and the binomial is that we don't know the probability of each trial, but we know average probability for that trial by measuring, or maybe by some data collection. You will see in the next example how it looks like. And we draw the random samples with replacement, and this is the formula, and then this is the count or number of the events in the sample. NP is the average count. Sorry, this one is not D, this one is the C. C is the count or number of events in sample, and then NP is the average count or number of the events in the sample. So let's see in an example how it looks like, the formula. So we observe that on average 10 products arrive every hour. Okay, you see, we don't know exactly. The part here says we don't know the probability of each trial, but we know average. So here you can see on average we know 10 products come. So exactly not known, but some measurement allows us to know approximately, or in an average way. In an average, we know that 10 products come. The question says that calculate the probability that exactly 5 products. As you go to the formula, C is what? Exactly the number of events. Okay? Exactly 5 products will be delivered every hour. The actual number here, you can see it can be 10, 14, 20, but on average, we know it is 10 products. The question says that what is the probability that exactly 5 of them will come? So our C is 5 and the NP is 10, which is the average one. So if I just put the formula back here, so the probability that X is 5 is equal to that NP to the power of C divided by C factorial and times the exponential of negative NP. Okay, so if I replace the values back here, so NP is 10, C is 5, factorial is 5, then exponential of negative 10. Okay, this is the value that we need. So let's solve it in Excel again, and then so it will be that 10 to the power of 5 divided by 5 factorial. Let me see, factorial, yes, of 5. Okay, so this part is 833.3, and then times this one again times exponential of -10. Okay, so it means that 0.03783, or you can say that 3.783% chance that exactly 5 products will be delivered. Okay, this is how the Poisson distribution works. And then, as I told, we have the continuous distribution as well. And for the continuous distribution, we don't know like the Poisson, like the binomial, we don't have the exactly 5 or 4 or 3, but we have the range of the values. Okay, and this one is like, for example, the weight range is continuous, but the number of defective light bulbs is discrete. The continuous one, so we have lots of continuous distribution functions, but we covered one in our class, that is normal distribution. I will not go in details here again, but normal distribution is just a continuous one where you have the range of values. So it has continuous properties, and for continuous distribution you cannot find the probability of x is 5. Okay, you cannot do that, but you can find the probability of 5x is 8. You can find the range, but you cannot find the exact value. Okay, this is the main difference because I said the properties are continuous. You don't have like that is continuous means that there is no like exactly 5. There is 5.0125. This weight goes to infinity. So therefore, we don't check exactly the number that we need, but we check the range of values for our case. And then we talked about central limit theorem that says that whatever distribution you have, the final is the normal distribution that is built from the average of those distribution. And this is also another concept that is important for normal distribution. Mean, mode, and median is the same, and it has a function that we use. And then roll of dice, it was discrete, but it was in the shape of the continuous, in the shape of normal distribution. Okay, this is the, and I should say one more part, that this all have a functions. So functions means that it is like this one, or it may be like this one. Okay, so but for this one, for the discrete part, so there is no function. Let me show you. There is no function here, but here we have the range of values, like this one, we have this one, and we have this one. You see, discrete, but exactly, for example, 5 is exact, but for here it is not exactly 5, but it is between 5 and then 8. Okay, here, or for example, we look for that 4 between 9. We don't look exactly 4 because there is no exactly 4. Okay, and that is the end for the probability section of chapter 7. And next chapter is about the attribute charts, attribute control charts. Thanks for watching.